this again, right? Let's go again through this here. So initially we got our normal vector. If they're the same magnitude, they have the same letter, A, right? If they go in opposite direction, it becomes negative A. If we double it, it becomes 2A. If we combine vectors like A and B, then let's say A is capital AB, it's going to be with this little arrow at the top over here. That's going to be vector A, meaning exactly the same thing. And then you got BC, which is vector B. And if I want to go from A to C, it's going to be travel on the path of A to B to C. So it's going to be A plus B. Another way to write this would also be to basically say this is equal to vector AB plus vector BC. But now I decide, okay, well, I want to take a path from A to a new point, D. Okay, so I've got this other point D, and I'm told that vector BD as a ratio to DC is 1:2. So that means this is one part and this is two parts. Now I can actually say vector BD is actually equal to 1/3. This part is 1/3 of the whole thing. 1/3 of BC. But what is BC? BC is vector B. It's going to be 1/3 of B. Let's have a look at another example. Or before we look at another example, let's look at firstly getting DC actually. So we have DC. DC over here is going to be 2/3 of BC, and that's going to be 2/3 of B. So that means this part over here is 1/3 times B, and this part over here is 2/3 times B, because when you add them up, it's going to be B in total. Now I'm traveling the path. Let's say I want to get from A to D. Okay, I know what AC is. I just said AC is A plus B. So that's A plus B. I know that this over here is 1/3 of B, and I know that this over here is 2/3 of B as well. And it's going in that direction. Okay, it's quite important. If this direction is 1/3 B, then the opposite direction is going to be negative 1/3 B. And the opposite direction of this would be negative 2/3 B. And if you go the whole thing backwards, it's negative B. Remember, opposite directions mean that the vectors become negative. This one's going to go negative A, and etc. All right, and A plus B is in this direction. So if you go backwards, this is going to become negative A minus B. If I want to go from A to D, I can travel a pathway. Okay, let's see what pathway I can travel. I'm going to go from A to D. If I go from A to D, there's nothing on this line. I don't know how to get this. So what I'm going to do is I can go this way, which is AB. After that, I can do BD like that, right? So let's write that down. So AD can be given by a vector AB plus vector BD. Now remember, AB is A, and BD is 1/3 of B. That's equal to A plus B over 3. And that's going to be vector AD, A plus B over 3. Now you might think, okay, well, what if we went the other way? Shouldn't we get the same result? If I went this way and I said AC and then CD, shouldn't I get the same result, right? I mean, either way, right? So if I got A, C, if I want to go from A to D, again, it can be given by AC plus CD. Now remember, if you're going from A to C, it's going to be A plus B. This over here is going to become a plus b. If you can go from c to d, you're going to go in the opposite direction of that, which is minus 2 over 3b. So I get b, which is b minus 2/3 of b is a third of b, right? So it's a plus b over 3, and you can see they're exactly the same. So whether you go that way or whether you go that way, you can still end up with the same resultant vector for this. Let's look at a quick example, and let's say you can think about this one. Let's develop a few vectors here. Something on the line similar to that one, but we'll change all the letters. All right, so this is A, B, C, D. And I'm told that this is A, this is B, and I am told that this vector over here, this whole vector over here, so let me just write this here. This whole vector over here is vector C. Okay. And the question says, so we're given also that AB as a ratio to BC will be given by 3:1. And then that means this is 3 part and this is 1 part from there. All right. So think about that for a second. And the question is now asking, find vector dA in terms of A and B. All right, so that's my question. Find vector dA going from there to there in terms of A and B. All right, let's do that as question 1. Okay, give it a go. Let's see if you can do that. Draw it up and see if it makes sense. Get a blank page, try it. All right, let's have a look at this question now. So for this question over here, it says here, find dA. Okay, so we want to find vector dA. Our goal is to go from there to there. Okay, so I want to find vector dA in terms of A and B. I need to find all these missing pieces. And I first need to know, how do I get to D, from D to A? I need to choose a pathway. So I can go like this. I can go from D to B, and then B to A. And at the same time, I can also go from D to C, and then after that, C to A. All right, so I have 2 possible options of going from DA. So let's work out both of them. All right, so here we go. So vector dA is equal to, so going from D to A, we can go dB, vector dB, plus BA. Do we have vector dB? Yes, we do. That vector is vector A, dB, right? And do we have vector BA? No, we don't. But we do know this is 1 part to 3. So we know that this is 1 and this is 3 parts. And we also know that vector C goes downwards. So let's quickly have a look at what this means. What we're saying over here is that vector AC, if I just have to redraw it over here at the bottom, we're going from A until C, which is that part over there, is known as C. And then there's a point over here, B, on this line. And that point breaks this up into 1 and 3. This is going to be a quarter, so 1 over 4C. And this is going to be, so that's 1 over 4C, which means this is going to be 3 over 4C. All right. And both of them are going in the same direction. Both of them are going in the same direction. This is going to be going from A to B. And this is going to be going from B to C, like that. Okay. We got 3/4 of C from A to B, and 1/4 of C from B to C. Okay. I need to go from B to A. So that starts at B and goes this way in this direction, which means I need to go this way in the opposite direction. So that becomes -3/4C. Can you see that? Because positive is down or towards the down movement, and up towards the left is -3C/4. So going BA means starting at B, finishing at A, is going to be -3C/4. And I'm done. I've got vector dA. Okay. The other way I could find vector dA would be to use vector b, which would be exactly the same as this, but it will have a b in it. So vector dA, let's see how it goes. So vector dA, to go from D to A, I can go on the blue route from C to A. So it's going to be DC plus CA. Now DC, remember, is B. And CA is going to be going in the opposite direction. And the opposite direction is -C, because downward direction is positive C, opposite direction, -C when it comes to CA, because AC is going to be it. So we could easily label these as well on the side here. So we know that AC is equal to C. We know that therefore from that CA is going to be -C. So that's going to be B minus C. All right. There we found vector dA over here. Okay. We answered the question. We found vector dA in terms of A and B. Well, we actually found it in terms of A and C, or B and C. But they actually equal to each other. All right, that means I could equate them. So A minus 3C/4 will equal B minus C. And they both equal to vector dA. So how would I incorporate both of them to be in the same equation? Do I need to for both of them? Maybe, maybe not. I can make C the subject of the formula in either and get it in terms of dA. Maybe that will help. So let's say I take this vector over here, which is, let's bring it over here. It would be dA, vector dA is equal to A minus 3C/4. That means 4 vector dAs is equal to 4A minus 3C. And so now I'm going to move this 3C across and become 4A minus 4dA. All right, so I move that, made it positive, and I move that over, made it negative. Dividing by 3 on both sides gets me C equals to 4A minus 4dA over 3. Okay, that's coming from B. From here, I can see that I can just rearrange this and swap the C over. Remember, this is dA. So let's swap those two guys over. So C equals B minus vector dA. Now we have two vectors that are equal to C. We have this vector and this vector, which is both equal to C, so we can equate them. B minus vector dA is going to be equal to 4A minus 4dA over 3. We want to find dA in terms of A and B. We have A's and B's and we have dA there, so on our route, on our way, we're going to multiply everything by 3 to get rid of the denominator. So we're going to have 3B and 3dA. And this is going to become 4A minus 4dA. And so if I move this backwards, this is going to become vector dA, because minus 3 plus 4 is dA using knowledge of equations. And 4A minus 3B is going to be the final answer there. 4A minus 3B would be vector. In terms of A and B, This is 4a minus 3b. In terms of a and c, it's that. In terms of b and c, it's that. But in terms of a and b, it's going to be 4a minus 3b for that thing.